Welcome back to the channel. It's the Earth Science Classroom. This video is going to look at how I draw the diagram for the Earth's interior project that the students will do in class with research and their own poster, and how to create a to-scale diagram of the Earth's interior. This is the Earth Science Classroom. Before the students draw their to-scale diagram of the Earth's interior, they first have to do research on the different layers, the various characteristics and facts and figures about both the chemical layers, the core, mantle and crust, and also the physical layers, which is more detailed, which includes the inner core, outer core, the mesosphere or lower mantle, the asthenosphere, lithosphere, and the two types of crust, oceanic and continental. In order to produce a to-scale diagram of the Earth's interior, we have to use a certain size poster paper, but also understand dimensional analysis. So add a little bit of math into this project and asking the students to find the depth or the thickness of each of the layers of the physical Earth's interior. So there's 6 layers in total. And then from there, they have to figure out the to scale unit that they'll put onto their poster for each layer. So it will be accurate and scientific in regards to the thickness on the poster, and the ratio is 1 to 10 million. So 1 centimeter on the poster they draw is equivalent to 10 million centimeters in length in real life. So that scale is 1 to 10 million. They can use this math formula or math technique of dimensional analysis to go from the kilometers or miles they find in their research and convert it down into the correct value or measurement in centimeters. So once students have completed their research on their layers, including the characteristics, the stats, the figures, and all of the required information to then put onto their poster and create this to scale diagram. So I'm using a large piece of 4-ply white paper which measures 22 inches by 28 inches, and that will accommodate the size of the poster or the diagram you need for the Earth's interior. So the scale is 1 to 10 million, which means that if the Earth's depth from surface to the inner core, the center, is 6,400 kilometers on average, then using the same scale, it would work out to be 64 centimeters in length, going straight down vertically. So I put a point there, then I add in the 2 sides of the triangle, and then add in a little bit of labeling for the Earth's surface at the top. And then once you have that basic structure and the outside of the triangle or pizza slice drawn, you can then start to add in your different physical layers, the 6 layers. And you can add it in according to the correct to scale thickness or depth of each layer. So with the crust, it will be on average 0.35 centimeters in this scaled down version. Again, it's average. And then the lithosphere at max is 1 centimeter, or could be 0.7, depends on what journals or textbooks you use or information online. Then we're looking at the asthenosphere, which is going to be an additional 6.7 centimeters down, which is the upper mantle. Then we're looking at the lower mantle, the mesosphere, which is additional or extra 22 centimeters down from the asthenosphere, that red line. So measure down 22 for the red line, and you get the point of the core mantle boundary at the bottom of the mesosphere and at the starting point of the outer core, which is this blue line, this core mantle boundary. Then you can measure down the thickness of the outer core, which is again around 22.7 or 22.5 centimeters in thickness, and that would be the boundary between the outer core and the inner core, which is this black line. And then we're going to have the inner core, which measures around 12 centimeters, which you don't need to measure down because you have that point of the center of the Earth, which you measured prior. And all you do is add in the details, the labeling, and I'm just showing you the exact measurements. And then the students can go on further in this project and add in all their research onto this poster, either in the triangle on the layer itself, or on the side, or if they want to expand further into more detail about certain layers, perhaps the crust or the silicate minerals or the outer core and the EM field or the asthenosphere and the convection currents or the transition zones or the LVC, low velocity zone. You can do that on the back, whatever you want to do and however high of a level you want to take this, you can with this project. It's pretty awesome and a great way to introduce the dynamics of crustal deformation and how and why the crust actually moves in terms of plate tectonics. If you liked it, please subscribe, like and share, and if you want more content and videos on earth science, please check out my channel.